Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a new numerical which is based on power series expansion, problem number 2 that we are going to study right now. Now, basically, whenever a causal sequence is given in the power series expansion method, whenever a causal sequence is given, then always try to calculate the amplitudes for a positive sequence. And whenever a non-causal ROC is given, then always try to calculate amplitudes for a negative time sequence. So first of all, let's go through the question so that you will get the idea how you are going to place a denominator part, or how you are going to arrange a denominator part to divide a numerator and to get the positive time sequence or amplitudes for positive time sequence. Let's see. Problem number 2. Determine inverse z transform of a function x of z is given 1 upon 1 minus 0.5 z inverse plus 0.5 z to the power minus 2, but using a power series expansion method. Here, first ROC is given where mod z is greater than 1, and the second ROC is mod z is less than 0.5, which means here we have to calculate, in first part we have to calculate amplitudes for positive time sequence. In second part we have to calculate the amplitudes for negative time sequence, that is for non-causal time sequence. So we will calculate first of all amplitude for positive or causal time sequence, and then later on we'll move on to part 2. First of all, we'll calculate amplitude for positive time sequence or causal time period. Now here mod z is greater than 1. Now what we are going to do, we are going to numerator by a denominator, but how to get the positive time sequence is much more important. So first of all, if we divide this one by a decreasing order of z, then automatically you will get the positive time sequence, and if we divide numerator by increasing power of z, then you will get the non-causal time sequence or amplitude for a non-causal time sequence. So right now I am dividing numerator by decreasing order of z. So first of all, here the power of z is 0, then the power of z goes on decreasing. So we'll multiply it by 1 so that you will get 1. So just multiply this one with the whole divisor part, what you will get. Now when we want to cancel this 1, then change this sign. So automatically next number sign will also get changed. So this 1 minus 1 will get become 0, and this sign will be changed, so you will get plus 1.5 z inverse and minus 0.5 z to the power minus 2. Now tell me which term you are going to multiply with 1 so that you will get 1.5 z inverse. Of course the result is 1.5 z inverse. Now just multiply this 1.5 z inverse with rest of the part. So 1 into 1.5 z inverse, result is same, but 1.5 into 1.5 result is 2.25, and we have z to the power minus 2. Then 0.5 into 1.5, answer is plus 0.75 z to the power minus 3. Now again we will change this sign so that the first term will get cancelled. So what we will get? Plus 2.25 z to the power minus 2 minus 0.5 z to the power minus 2. What we will get? Answer is 1.75 z to the power minus 2, and minus 0.75 will remain as it is. Now next, I am going to multiply this one with 1.75 z to the power minus 2 so that you will get the same result, and these two then terms will get cancelled. So what we will get? Just multiply this part with this whole equation. So after multiplying, what I have got, 1.75 minus 2.625 z to the power minus 3 plus 0.875 z to the power minus 4, and I have changed this sign so that this two term will get cancelled, and after changing this sign, 2.625 will have a positive sign and 0.75 that will be subtracted from this. I have got this result now. And next one, 1.75 into 0.5, I have got this result, and the sign will be changed. That's why I have written minus 0.875 z to the power minus 4. Now if I want to divide it once again further, so what we are going to do, we'll multiply this one with 1.875 z to the power minus 3, so that we'll get the same result, and these two term will again get cancelled. So I'll write here 1.875 into z to the power minus 3. Now if we want to divide, then you can move on, but I'll stop here, and this value will goes on till infinity. Now this is my x of z, or the result x of z. Now I'll compare this result or question part with the definition of z transform. So according to definition of z transform, I am going to compare this quotient, or you can say the result of x of z, with the definition. Now look at here, we have solved this part, but for causal ROC, which means we have to change this summation value into a causal period. So this summation value changes from 0 to infinity. Now break this summation from 0 to infinity, or you can say substitute this n value from 0 to infinity. So first of all, I put n equals to 0. Now look at it, if I put n equals 0, then x of 0 we will have, but z to the power 0 will give us value 1. So I'm not going to write that value. Now next, I'll substitute n equals to 1. But listen, for a positive time sequence or for positive values of n, the order of z is always have a negative sign, or the power of z is always carry a negative sign, because in the definition we already have z to the power minus n. So if the n is positive, then the power of z is negative, and if n is negative, then power of z is positive. Now how to identify which time sequence you have got? Just simply compare the x of z. Just simply compare the z values or z powers in x of z. Here all the signs are negative, which means we are going to calculate, or we are going to find out of amplitudes of x of n for a positive time sequence. Now I am substituting next values of n, but for positive time sequence. So look at here, I have calculated only for to n equals to minus 3. Now next one, here I have substituted n equals to 1, 2, 3, and all the orders are changes to minus 1, minus 2 and minus 3 respectively. Now simply compare both the results. Let's say this is my equation number 1 and this one is my equation number 2. So compare the coefficients of z from 1 and 2. What you will get? X of 0 value is 1. Next, x of 1 value is 1.5. That we can write like a 3 by 2 also. Now if you want, then you can write this value in fraction part also. Now x of 2 is 1.75, so we can write or represent it by 7 by 4. Next one is x of 3, 1.875, and this can be represented by 15 by 8 and so on. So basically what we have done, we have calculated the amplitudes of x of n for n equals to 0, n equals to 1, n equals to 2, n equals to 3. So we can represent it in like why is this? Now look at here, this one is actually placed at origin, because we have got this one value for x equals to or n equals to 0 or at x equals 0. So I will mark perfect arrow perfectly below to that of 1, which will shows us or gives us the idea this is my origin, and on the right hand side we have got the positive time sequence. Now we will calculate the negative time sequence. Now the second part. Here mod z is less than 0.5, which means we are going to calculate the amplitudes in non-causal time period. Now how to get the non-causal time periods or amplitudes at non-causal time period? As I said, just keep the denominator value in, or just keep this z power in increasing order. So lower order is z to the power minus 2 and higher order is z to the power 0. So we will write this z to the power lowest first on the leftmost side and the highest on rightmost side. Now which term you are going to multiply with z to the power minus 2 so that you will get answer 1. So I will tell you the shortcut also. Look at here, what we want 1, and which term you are going to multiply with 0.5 z to the power minus 2. I will represent it by x. This x value is multiplied with 0.5 z to the power minus 2. So that after multiplying you will get answer 1. So simply do one thing, just shift this whole part on the right hand side. Now look at here, 1 upon z to the power minus 2 will become z to the power plus 2, and 1 upon 0.5 is answer is 2, which means if I multiply 2z square with 0.5 z to the power minus 2, automatically you will get answer 1. So just do one thing, multiply this whole value with this whole equation. So after multiplying first two values or first value with the 2z square, of course I will get answer 1, but move on to next. 2 into 1.5, answer is 3, but minus 3. Z to the power minus 2, and here we have z to the power minus 1. So minus 2 plus minus 1, answer is z. And last one, here we have plus 1, so answer is 2z square. Now we'll change this sign so that this both the numbers or 1 will get cancelled. So what I have got, 3z minus 2z square. Again do the same thing. What we want, 3z, and which term you are going to multiply with this whole one so that you will get a 3z. So if you want, then you can do the same thing. Just multiply 0.5 z to the power minus 2 into x, and you have to calculate 3z. Shift this 0.5 z to the power minus 2 on right hand side. Now look at it, this z to the power minus 2 is in denominator, so if I shift it in numerator side, then this will become a plus 2, and this z to the power 1 and plus 2 will get added. So what you will get, z to the power 3, and 1 upon 0.5 is 2, and 2 into 3 is 6. So if I multiply z 6z cube with 0.5 z to the power minus 2, we will get 3z. So just after multiplying, of course I will get 3z, but next minus of 1.5 into 6, answer is 9, and z cube into z to the power minus 1, answer is square, and the last one is 6z cube. Again change the sign so that 3z will get cancelled. So 9z square minus 2z square, answer is 7z square, and at the end 6z cube. Now which term you are going to multiply with 0.5 z square or z to the power minus 2 to get this 7z square. So my suggestion is simply just divide this value or perfectly write this value in the denominator of 7z square. What you will get, this minus 2 will be shifted in numerator, so that this will be z to the power 2, and z square into z square, of course the result is z to the power 4, and this 0.5 shifted, 1 upon 0.5 is always 2, and 2 into 7 is 14, so we'll write 14 over here. Of course, so 14z to the power 4 multiplied with 5z to the power minus 2, of course you will get this 7z square. Now do the next thing. 14 into 1.5, this whole 14z to the power 4 will be multiplied with next two values, and then I will do the subtraction. Then let's see what result you will get. So after multiplying 14z to the power 4 with the rest of the part, I have got this result. Now just by changing its sign, this 7z square 7z square will get cancelled. The 21z cube sign is changed to plus, and so plus 21z cube minus 6, answer is 15z cube, and this minus sign will changes the value of to minus 14z to the power 4. Now if we want to divide again, then again just shift this value in the denominator of 15z cube. Now look at here, 3z upon 5z square. What happened? This z we have already power 1 and here we have already power 2. So minus 2 value is shifted in numerator side. So the power will be positive and hence both the powers get added. That's why we got z cube. Now next one, 1 upon 0.5, answer is 2, and that 2 will be multiplied with the 3. That's why we have got the 6, which means 1 upon 0.5 will give us a value 2, and 15 into 2, answer is 30. And here we already have z to the power minus 2. So if it shifted on numerator side, that power we have 3 into z to the power 2, answer becomes z to the power 5. So if we want 15z cube, then we'll multiply 30z to the power 5 with 0.5z to the power minus 2. So if you multiplied it, just do the next division and you will get the answer. But if you stop here, then also it is fine. Now this quotient is nothing but my x of z. Now we have got this quotient part or the result, but for non-causal ROC, which means we have to change this summation value to non-causal. So your non-causal period started from minus infinity to minus 1, not up to 0, and x of n into z to the power minus n. Now just break this summation value, but substitute here n value from minus infinity to minus 1. But look at here, if my n value is negative, then automatically the power of z is positive. So I am substituting the leftmost value of n, which is minus infinity, so automatically the z power becomes positive, and then I'll start from z to the power or n equals to minus 5. Now listen, I have substituted the values from minus infinity to minus 1, but I have just simply added x of 0. If you want, then you can write it, but basically according to summation value, this value should not be here. Now why I have written this value over here, I'll tell you later on. Just simply now compare the coefficients of equation 1. Now simply compare the coefficients of z from equation 1 with equation 2. What I will get? Z to the power 5, here also we have z to the power 5, means x of minus 5 value is 30. Similarly, x of minus 4 value is 14. X of minus 3 is 6 and x of minus 2 is 2. But we have an order up to z to the power 2. We don't have any value for z to the power 1, which means my x of minus 1 sample is absent. So my x of n becomes, we have not calculated this value till minus infinity. We have calculated up to minus 5. That's why I'm going to start from minus 5. So at minus 5 we have got the value which is 30, then 14, then 6, then 2. But at x of minus 1 we don't have any value in x of z, so we will write only 0. And why I have written 0? Because to mark the origin value, so that you will get the idea. On the left hand side we have got the negative sample amplitudes. So this is all about a power series expansion. Thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda. Thank you so much.